Welcome to bmnteam.com. In this tutorial, we will start talking about Typescript, and the first lesson will be about generic type, which is a very useful feature of Typescript and might be new for those who didn't have experience with strongly typed languages. But as far as we dive deep into this aspect, we will see a lot of benefits by using generic type. So let's start by creating a simple user service.ts file, which will have a relevant class, user service. This class will receive some HTTP client or user service interfaces in the constructor in order to connect data with external API. Let's define user service interface with such method as get with one param. Let's create our user's returning model in a separate models.ts file and make it just a multi-class. A simple user will have three fields, such as ID, which type is number. The second will be first name, with the default value as Maxim. And the last one is last name. Let it be just B. Then let's declare an import statement by specifying relative root to models file, and then add exported user model. So get method will return user model. Add method accepts user model and returns the Boolean result. Update method with the same signature and returning value as the previous one. And delete with ID as a parameter and Boolean as returning value. Let's use just defined interface. Firstly, the get method in the class will return user from provided user service through get method. Also, we need add method in order to create new user. This method accepts user model and returns Boolean as a result of operation in the provided service. Update method has the same signature as the previous one and also use provided service, which is responsible for communication with external API. And the last method will be delete, which receives identifier as a parameter and returns operations result as a Boolean type by using the same service. In order to test our new user service, let's create a user model. So we create new instance of user service, and the argument of its constructor should be a model which implements user service interface. But we will mock our service by providing only get method for testing purposes, and we'll treat this object as user service interface. And then get user from new instance of user service class. As you can see, we receive user model because it has all fields this model requires. And for now, nothing bad happened in this approach. But we are not only limited by a single class in our application. So let's create seller class. It also be just mock class with default initialization in the constructor. Seller's model will have two fields. First one will be ID with default value as 1, and the second one will be account number with default value as 1, 2, 3. Then, in order to manage this model, we also need service, which will be almost the same as user's service. So let's copy and paste our user's service.ts file and rename it to sellers service.ts file. Instead of importing user model, we will import seller model. It should be also replaced in provided service, and the service interface should be renamed according to the seller model as the same as the class. Then let's replace usages of user model in our class by seller model, because now we only need to deal with seller instead of user. Also, we have to rename user service fabric constant name, returning model in mocked get function, and the mocked interface itself. As you can see, our seller model doesn't have first name property, which user had. Instead, we can check account number in order to make sure that the received model is the seller. All in all, we've just duplicated more than 30 lines of code in order to achieve the same functionality with only models differences. Let's move towards understanding generic approach. Firstly, copy seller service to models.ts file in order to avoid interfaces duplication. Now we can declare that our returning value may not only be a seller type, but also a user. But as we grow, we will have more classes, so this approach is far from robust. Let's make our common service interface generic by specifying its type as T after interface's name, and replace all models in interface by generic type. T is a common abbreviation for generic type. We export common service in order to use in generic service. As we already have all required functionality in other services, let's create generic service from existing seller service and call it generic service.ts. Firstly, replace unused seller service by common service interface, which should be imported from models.ts file. But now our interface is generic, so we have to specify type for it. But the main goal is to make our service generic. So let's do it. And now we have type for our interface, which is the same as service type. But what if we don't want to be limited by common service in our constructor and want to use other services which extends common service interface? In order to achieve this, we can make specific type for provided service as a first type parameter and the model that we are using as a second parameter. So now T is a type for provided service and U is a type for model we are dealing with. Now we have universal generic service, which can be used for dealing with all models, and GCP services, which implements common service interface. It's a good time to try it out. Firstly, let's get new user using new instance of our generic service, which expects type definition for service as a first parameter. And do not forget to import definition for our user model as a second parameter. The next step is the same as we did for traditional user service, where we just mocked get function. And now we treat it as common service interface with user model generic type instead of a user service interface. As you can see, we get user through generic service. So let's receive a seller with this approach. We have to replace common service parameter type to seller as same as the second parameter. Mock get function should return new seller instead of user. The same changes must be applied to treated common service interface. Our generated user constant is of a user type because it has all fields this model requires. The seller constant is a seller type for the same reason, and both these constants has been received from the same generic service. So now we know how to reduce code duplication for interfaces and classes. Let's move on and deal with functions. create shared.functions.ts file in which we will make function to create dictionary from users. We call it as getUsersHash. This function will have one parameter, which is array of users. Do not forget to import user model from models.ts file. Function will reduce given users array to single dictionary object. During iterations, we have accumulator and current objects as the first argument, and the default value for accumulator as a second argument. Our dictionary will be an object with key as a string type and value as a user type. Accumulator object will have ID as a key for dictionary and a user itself as a value. After setting each pair, we return accumulator for the next iteration. This function has to be exported in order to be used in other modules. All this structure could be a little bit simplified by using comma operator, which evaluates each operand from left to right and returns last value. Let's implement just created function for our generic service. In order to create dictionary, we will need array as an argument. So let's duplicate our user and seller constants and rename it accordingly. Then we know that in the constructor we set default value for ID parameter, which is equal to 1 in both cases, but it could be also set in each constructor individually. So let's provide ID for sellers and users constructors and receive them by specifying ID for get method. In order to receive users dictionary, we will use our getUsersHash function and provide array of just created users as an argument. So let's try to get sellers dictionary. We will use the same function, but in order to receive sellers dictionary, we provide sellers array as an argument. All in all, we've got type error because function expects array of users as an argument. So in order to deal with sellers dictionary, we can duplicate code for getUsersHash function, then rename it and specify another type. But now we already know about generic approach. Let's create universal generic function. Firstly, duplicate shared functions.ts file because it has all required functionality, and save it as shared generics functions.ts file. Let's call function more abstract, then declare as a generic by specifying type T, which should be a type for argument and the returning record value. But we know that our type T ought to have ID field, so it means that T should extend some interface with ID field. In models.ts file, export hashable interface with ID field, which all our dictionaries will implement. Then, in function expression, define that type T extends our hashable interface. Make sure that you import interface from models.ts file. I reckon that it's a good time to replace our hard-coded function with a generic one. Then we have to define type, which is user for users hash. For sellers hash, we will do the same, but type will be seller, and error disappear. In our users hash, we have user with ID 1 as key, and its value is a user type because it has all fields user model requires. The same conclusion could be applied for seller's hash. To sum up, in this tutorial we figured out how generic works in interfaces, types, classes, functions, etc. You can apply this knowledge in order to make your application more robust and maintainable. Hope this information was useful for you. If you like that kind of content, do not forget to subscribe. You can also find full article about generic with code examples on bmanteam.com. See you in the next video.